Thank you for joining us today. We are going to talk about Android Oreo 8.0 and the Visual Studio tools for Xamarin. My name is Tom Opgenorth, and I'm a senior content developer on the Xamarin Docs team. My job is to help with creating a lot of the content and guides, samples, that kind of a thing, with a focus mostly on Xamarin Android and Test Cloud, also known now as App Center Test. During the course of this discussion, you're probably going to have some questions that pop into your head from time to time as we go through the various topics. Don't worry, you don't have to save your questions to the end. Just type them in the discussion box at any time. We have got several experts standing by, ready to take your questions and get you answers in a timely fashion. Let's just have a quick overview as to what we are going to be discussing. To begin with, we'll talk about installing Android Oreo 8.0 and what you need to do so that your apps can target it. Then we'll tackle some of the exciting new features that are available. Just a high-level overview to kind of give you an idea of what they are, what's involved, and what you can do with them. Then finally at the end, I'll give you some resources that you can follow up with on your own time. And we'll save a few minutes for questions and answers, just for any last minute things that might have popped into your head. Let's look at what's involved with installing Android Oreo 8.0. You can install Android 8.0 using the Xamarin SDK Manager. This requires Visual Studio Tools for Xamarin, version 15.4 or higher. How do you know if you have this particular version of the Visual Studio Tools for Xamarin? Well, if you're tracking the stable channel, then you'll have it. You can be able to find the Android SDK Manager under Tools SDK Manager. When you run it, it will appear in one of two ways depending on which IDE you're using. Now in Visual Studio for Mac, which I'm showing you here, it will appear in the Preferences dialog for a given project. In Visual Studio 2017, it will appear as a startup, or it'll appear as a standalone application. It'll start up that way. Either way it starts up is fine. They both get the job done. So let's just take a quick peek here at some of the bits and baubles you'll need. First off, the Android 8.0 Oreo. Within there are some choices. You'll definitely need the Android SDK Platform 26. That's the actual API itself that you want your application to target. Sources are optional. Those can be handy for if you're curious about what Android is doing under the hood or you want to unravel why something isn't working. Sometimes it helps to have the source code for that. And then following that are a bunch of AVD images. I'll leave it up to you. If you use the Android emulator, though, you'll definitely want to install the Google Play Intel x86 Atom system image. That's the one I have called out there. And the reason I bring that to your attention is, by default, a lot of the AVD images don't have Google Play Services installed. And as we know, Google Play Services, they provide a lot of features and functionality that our apps rely on. Or maybe our apps are using a library which relies on something from Google Play Services. And it can be very frustrating to try and use the emulator without Google Play. So Google ships us an AVD image. If you use the emulator, you'll definitely want to install that guy. The next thing we'll just quickly look at here is the Tools tab. And in particular, you'll want the Android SDK tools installed, probably the most recent supported version, and the same thing for the build tools. Now you'll notice here with the build tools, I've selected 26.0.2. At this time, I know that version is supported by Xamarin Android. It might be tempting whenever there's a beta version of Android to be released to automatically just jump ahead and install all those little bits and pieces. That can cause a bit of a problem because they may not be bound or supported by Xamarin Android yet. So, just to be on the safe side, stick with the build tools that you know. You can usually find that out by taking a peek at the release notes for each given release of Xamarin Android. Inside there, that will tell you or will provide information as to what version of Android things are supported. Next thing you want to do is actually have your app target Android 8.0. So the first thing you do is you would look in the project options for your Xamarin Android project, and you'll want to select the target framework. This tells Xamarin Android that when it is going to actually compile your project, to use this version of the framework. So by using this version of the framework, we will have access to Android 8.0 and everything. You'll notice this setting here is use latest installed platform, and that's kind of a way of letting Xamarin Android infer that because you have the latest and greatest installed, that's what you want to build your project with. And it saves you from having to go in there and bump this every single time there's a new version of Android that comes out. The other two settings you'll need to take a quick peek at is the minimum Android version. This is basically identifying the lowest version of Android that your app supports. So in other words, in this example here, this app will run on Android 5.0 or higher. It will not run on Android 4. The other one, target Android version, says this is the version of Android I'm designing my app for. And you'll notice here it's set to automatic use target framework version. Again, that's a pretty safe decision, largely because every time there is a new version, it's just sort of the intent or the implication that you automatically want your app to target the latest and greatest version you have installed. And in this case, that would be the target version we saw in the previous build tab. So once you've made those quick adjustments, your app is pretty much set to target Android 8.0. However, there is one thing to have and you should be taking into consideration, and that is backwards support. Now, starting in Android 8, Google dropped support for anything older than API level 14. So that's Android KitKat is now kind of the lowest or the oldest version of Android that apps will run on that are targeting Android 8.0. Now, just because an API is available in Android 8.0 doesn't mean it's automatically going to work on older versions. And so this is where the support libraries come in. The support libraries v26 backport features to API level 14. It's important to realize that the support libraries themselves aren't just one library. It's not just one NuGet package you add. The bulk of the support library features are available via Android, Xamarin.Android support.compat via this NuGet package. However, there are some features that will require additional support library packages. And if you've been developing Xamarin Android apps for a while, you're probably already familiar with this, with things like the recycler view or the card view. They actually had their own NuGet packages you had to add into your application. How do you know what packages to add through NuGet to your Xamarin Android app? Well, this involves going and reading the Android documentation and figuring out what the Gradle dependencies would be, and then mapping those dependencies to NuGet. And here's just sort of a little rule of thumb I figured out that I used to help me with this, solve this little riddle. So first I would go and read the documentation. So as an example here, say we wanted to add emoji support to our application. You would go to the Android pages and you would see somewhere in there they would say that, you know what, to get emoji support in your app, you'll need to add this dependency to your Gradle file. We don't need to worry about exactly what a Gradle file is. We just sort of need to look for this type of syntax. In particular, we'll pay attention to that string there, com.android.support support-emoji 27.0.0. The 27.0.0 is just a version number. We don't really care about that for right now. The important part is the string before that. So to translate this to NuGetese, what I do is I take a look and I say, okay, the com.android.support maps to Xamarin.android, and the support:/support-emoji maps to support.emoji. I'll combine those two together, and that will give me Xamarin Android support.emoji. Then to verify this, myself personally, I like to go to the website, so I'll go to nuget.org and I'll run a search for it. And if it doesn't show up in the search, I'll make sure that I click the include pre-release and run the search again. So I'll head off to my IDE, and then using the NuGet package manager, I'll go ahead and install it. Let's get started talking about adaptive icons. Why adaptive icons? Well, the idea behind adaptive icons is that it is very possible that OEMs or even the app launchers want to convey a certain theme or a certain style to go along with their particular device or the way they work. And Google's decided to make this a little bit easier. So hence adaptive icons. They are an icon whose appearance can be changed by the app launcher or by the OEM of the device itself. It just allows sort of another entry point of customization slash branding for a given version of Android. Now, the way adaptive icons work is they are comprised of two layers, a foreground and a background. And then the launcher will take these two layers, combine them together, and then apply its own mask to change the appearance of the icon to fit with, again, the theme or the style of the device or whatever effects the launcher wants to apply to it. So, yeah. What are the rules? What are the rules surrounding adaptive icons? Well, in the large, they're very simple. They have to be 108 by 108 dp, and they have a 72 by 72 dp viewport. Now, that doesn't mean that the icon itself has to occupy that entire viewport. It probably shouldn't. Instead, there is the innermost 66 dp of that viewport, and that remains untouched. So this is the part, this innermost part that will not be touched, is guaranteed to always be displayed in the viewport. And why is that important? Well, let's just take a look here on the next slide. It is entirely possible that some launchers may want to apply a visual effect such as an animation to the app icon itself. And in that case, there needs to be a little bit of extra room for that visual effect to be applied. So in the examples we're showing here, the icon may vibrate within the viewport as shown on the left, or it may pulse a little bit as shown on the right. In either case, as long as your icon sticks to that protected 66 dp zone, it's always going to be displayed, and then the launcher has that padding on the side to play with and apply whatever visual effects it wants. Creating adaptive icons is just creating another drawable. That's all an adaptive icon is. As we can see here, this would be an example of an adaptive icon layout or an adaptive icon drawable that would be created and added to the resources folder of your application. It is a new element, adaptive icon, and it in turn is the parent to two new elements, background and foreground. And the background can be any other drawable. The biggest limitation there is that it cannot specify any transparencies. The foreground likewise is any other drawable. In this example here, it is a mipmap, probably the old or the original icon from the application, and it can be any drawable within your application or within Android, and the foreground is allowed to specify some transparencies. When it comes to creating an adaptive icon, right now the simplest solution is probably to go to Android Studio and use the Asset Studio wizard that comes with it. As you can see from this screenshot, you can create the launcher icons for both Android 8.0, i.e. an adaptive icon, and legacy icons. So the wizard here just allows you to identify the foreground layer, the background layer, and then you can feed it the asset type that you want to use for the icon. You know, maybe you have your own image you want to upload, maybe you want to use some of the existing clip art, maybe you just want some plain old text. And it will go ahead and show you the different styles of icons that will be generated. As well, it will go through and create legacy icons. So in that case, for apps that are older than Android 8.0, the wizard will just go ahead and generate the device, the density specific icons for each device. So it saves you a lot of lifting. You just use this wizard here. It will create all the necessary assets for you, and then you can just turn around and add them to your Xamarin Android solution, and it's all done for you. Next, let's look at notifications. In my opinion, notifications is debatably one of the more exciting changes that Android has introduced to Android 8.0. Largely because it gives a lot of control to the user now. Before, applications would just publish notifications, and that was that. The user had no control over, is this important to me? Is this not? How is this notification going to get displayed? That sort of a thing. Or if the user missed a notification, there really was no way about knowing about it. Say they weren't paying attention to the navigation drawer. They didn't see it there. So the first change that Android 8 brings out isn't a standalone change. Android 8 provides the support, but it's up to a launcher to implement it, and that is notification dots. Some of you might sort of think of these as badges, particularly if you do iOS development. But the idea is that when an application has notifications that are unseen by the user, a little dot will appear in the corner of the app icon, as we can sort of see here. And that is just a visual cue to the user that, hey, this application has something for you. So now when the user is interested in a particular application and its notification, it can see just the notifications from that app. So using the example here of the Gmail app, if the user were to long press on it, up would pop a little bubble and it would display the notifications from that app and that app alone. And so now the user is unencumbered by having to go and check Play or Allo or any of the other sort of notifications out there. They just wanted to see what was up with Gmail. They found out what was up with Gmail. The other great thing that notifications now provides us with are channels. And channels are just a way of grouping the published notifications in a logical fashion. So not a lot of notifications that are kind of logically related to one another are grouped together in a channel, or a category is sort of shown here. The idea being that users may care more or less about notifications depending on what they are. So using the example of the YouTube app here, we can see download notifications and general notifications. Download notifications, yeah, maybe that's important to me. If I'm downloading a video, I want to know when it's done downloading so I can then turn around and watch it. Or I know I'm good to go for my road trip and I don't have to sweat how am I going to watch a YouTube video because I'm in a place with no bandwidth. General notifications might not be as important. Those might be things like recommendations and that kind of a deal. I may not care too much about the recommendations. I can see those when I start YouTube. Within the channels themselves, the users have very fine-grained control over how that channel will display notifications. So they can, if we drill down into the notification examples here, a user can turn them on or off. They can change the importance of the notifications within this channel. And then they can tweak some of the settings with the notification channel itself. Like, should these notifications show a dot? Should there be a blinking light when there is a notification, assuming the device supports that kind of a thing? Should these notifications be shown on the lock screen? Should these notifications override my do not disturb settings? That kind of a thing. Gives the user a lot of control now over what they see and how they see it. So now we've understand what notifications are and the impact they have on the user. Let's see programmatically what we need to do. So to begin with, everything has to be published to a channel with Android 8.0. So the first thing you'll need is each channel has to have a unique string that identifies it within that application. We refer to that as the channel ID. We'll also need to know the channel name. So in this little code snippet here, we can see that we're getting the name of the channel from the application resources. Then we programmatically new up a notification channel object, and we give it the channel ID, the channel name, and we set a default importance. At that point, the channel is pretty much ready to go. If we wanted to, we can specify some other default values that we think the channel should have, such as the channel light. You display a green light for my notifications. Lock screen visibility. Well, these notifications are kind of private, so don't display them on the lock screen. Then from there, we get a reference to the notification manager, and we would just say, manager, create this notification channel. And there we go. The notification channel is created, and we can start publishing notifications to it. So what do we need to do to publish a notification to a given channel? Well, we need to know the channel ID. And then from there, a lot of it is just like the way it used to be. We use the notification builder with the notable exception that now we are also providing the channel that we are publishing this notification to. And then we set the properties on the notification using the Fluent interface of the notification builder. So we'd set the title, the text, maybe a small icon, that kind of a thing. All these things are set on the builder. Then, when it's time to actually publish the notification, we get a reference to the notification manager, and we call notification manager.notify, and we say, here's the notification ID, and we get the notification builder to build the notification for us. And that publishes the notification, and off it goes. So, that's notifications. Let's turn our attention now to background execution limits. So this is arguably one of the biggest changes in Android 8.0. The reason I say this is because it has a huge impact on how applications run, specifically their services, and it targets all applications that run on an Android 8.0 device. So your app doesn't even have to target Android 8. You will still be impacted by this. The long story made short is apps no longer can run freely in the background. Now, before, when we did stuff in the background, we used a service. And that service, for all intents and purposes, could run free in the background. It could do whatever it wanted, whenever it wanted, for however long we wanted it to do, within, constraints. Android was watching, and if it detected a problem, yeah, it would come in and put a misbehaving service to bed, so to speak, and shut things down for the health of the device. What you need to know is this is no longer the case on Android 8.0. And why is this no longer the case? Why all of a sudden this sudden clampdown? Well, it all comes down to load. Running background services, they can place a significant load on systems, and an unnecessary load. Having a whole bunch of services running all at once, all these services are competing for things like RAM, power, screen time, possibly bandwidth, CPU, all these sorts of things. Input, output, access, that kind of a thing. All of these things going on at once can really hammer a device. And the thing with services is a lot of times the user doesn't even know a service is starting. An app could start up a service as it's in response to certain events and that kind of a deal. This might not be a problem with a lot of the newer devices that have lots of RAM and fast CPUs and lots of those CPUs. However, for the older devices, or devices that are perhaps more for the budget-minded, those are going to have some significant hardware constraints. And let's be honest, it's really hard to effectively test across this broad spectrum. So to help deal with this, Google has sort of said, you know what, Android, maybe this unfettered running of services in the background isn't the best idea. Maybe there needs to be some sort of control on this, some sort of restraints on this. And that's exactly why we have this now, is to improve the user's experience with the device overall. And it also helps prevent misbehaving apps from dominating the device and ruining it for everyone else. The other thing here is that implicit broadcasts, they can thrash the system. Now, I'll give you an example here of what I mean, which sort of ties all of these things together. So an implicit broadcast is a broadcast which is sort of a to whom it may concern message of an event that has happened on the system. So let's take, for example, plugging the device in and charging it. There may be a whole bunch of apps sitting there listening for this implicit broadcast of the device is charging. That'll get published at the second and the user plugs in the device, kind of a thing. Android will publish that. Now all of a sudden you could have a whole bunch of apps that are wanting to start up to do some particular piece of work, i.e. download something in the background, perform a lengthy calculation, maybe make a whole bunch of thumbnails, start a backup, that kind of a thing. So right there, that's an example of, four things. Maybe there's more. Maybe there's 6 for the sake of argument. Because maybe there are 2 or 3 apps that want to make thumbnails when you plug it in. So now all of a sudden you have like 6 apps starting up, all hammering the device for what the limited resources on the device. As far as the user is concerned, all they did was plug in their device. Now, thanks to this implicit broadcast of the device is powered in or plugged in and charging, all they see is their device all of a sudden just slows right down to the point of perhaps being unusable. And now all of a sudden things aren't working well. their own ability to use this, what could have been a very expensive phone, this very expensive piece of hardware, is now impaired. And that makes them very unhappy. So what do? Well, they start installing these app killers, and they think that, oh, well, they can manage it. They know what should be running and what shouldn't, and they start manually shutting things down. Well, what happens then? Well, guess what? Android comes in and says, oh, well, this app was actually running before it was killed, so start it up again and restart the work. And the cycle repeats and continues. So the idea here is that Android needs to be more intelligent, not about work in general, but just how this work is scheduled and how it should happen. So in an attempt to put some controls on this, there had to be some limitations on background services and what they can and can't do. So this is effectively what happens, is as soon as your app goes into the background, and once it's in the background, it has a window of a few minutes to run its services and to let them finish up and do any work they need to do. Once that time window has closed, Android will stop the services, as if it had called the service.self method. So the app, at this point, it's all said and done, the services are all stopped, and it's in the background. It's not doing any more work. And notice, again, this affects all apps running on Android 8.0. So even though your app may not target it, it could still get caught up in this trap. And as well, users do have the ability to go into settings and turn on restrictions, background restrictions. So this is a very important thing to understand, that going forward, how your app works is going to need to change. So I've talked a bit about background and how your services get shut down when they go in the background and that sort of a deal. That sounds a bit scary, a bit ominous, of like, oh my God, all of a sudden nothing's going to work. Well, before we panic, let's just take a look at how we distinguish between an app in the foreground and an app in the background. The best way to approach this is, if my app is in the foreground, my services are okay. They're not going to be killed. They're not going to be shut down. And here are some general rules that you can count on when thinking about, am I in the foreground? So if your app is visible, it has some visible activity, whether it's started or paused, your app is in the foreground. Okay, so that one's simple and makes sense. The next one is if your app has started a foreground service. Now, a foreground service is a service which has been elevated to a foreground state. This is kind of a way of signaling to Android that this service is important, it's doing work for the user is aware of this work, and they're okay with it. So Android won't come in and shut down a foreground service because it knows that, hey, a foreground service is doing something useful. So two little things here that might get your mind thinking as to what you can do to mitigate some of these changes. Another example of when your app would be considered to be in the foreground is if it's providing some sort of feature or functionality that's being used by another app which is in the foreground. So let's take these first two here, bound to a service or using a content provider. If another app is using a service from your app or using your content providers, then your app will be considered to be in the foreground, and so therefore the services won't be shut down just because your app isn't front and center in the user's attention, in front and center in front of the user. The next thing is wallpapers. If your app is providing wallpapers, it's kind of sticking around. It's considered to be in the foreground. It's not going to die. And finally, are input method editors. So maybe you're providing your own keyboard or some sort of fancy new input technique for the user. As long as those IMEs are being used by your app or by another app, then your app too will be considered in a foreground. So these sets of conditions here define my app being in the foreground. If I don't meet any one of these, then basically when my app is no longer visible on the screen, it's in the background and it's eventually going to have its services shut down by Android. So how do we get around this? What are some tips and tricks for dealing with this issue? The first one, which is the one that's suggested by Google, is start thinking about work in terms of jobs and scheduling those jobs. Now, a job can probably be best described as a discrete unit of work that can run independently and can be scheduled at a time that Android thinks is appropriate to run that job. Now you as a developer can provide some constraints or conditions as to when that job should run, but ultimately when that job gets run is left to Android, subject to your constraints. There are two great APIs right now that provide this level of support. One of them is the Firebase Job Dispatcher, and the other one is the Job Scheduler API, or the Job Scheduler framework. The Firebase Job Dispatcher, it actually builds upon or will use Job Scheduler if it's available. The biggest difference between the two is that the Firebase Job Dispatcher is provided by the Firebase team, and the Job Scheduler, although built into the Android framework, is only available on Android 5.0. So this, in my opinion, is sort of another little hint that the minimum framework your app should be targeting is Android 5, because then you don't have to worry about what do I do about jobs on Android 4.0. Either one of these will work great. They have very similar APIs, very similar interfaces. So if you use one and you need to switch to the other, not a problem. My preference would be to go with the Job Scheduler API. However, both of them will work. Another trick you can do is to use Firebase Cloud Messaging. Now, when an Android app, or when Android receives a high priority Firebase Cloud message that is targeting a given app, it will whitelist that app and allow it to start and run services in the background for a few minutes. So this can prove to be very handy. You can schedule a Firebase Cloud message to come in at a later date and time, and when that message comes, your app will be be allowed to wake up and perform some background work. However, don't abuse this. I can see that if everyone starts doing this, that Google might turn around and say, you know what? This is getting out of control. We're clamping down on this again. So it's one technique. Use sparingly. Another option is just use a foreground service. This would be perfect for, say, media apps or navigation apps that are constantly hitting the GPS or are playing music, that kind of a thing. That way, your app is considered to be in the foreground and it won't be killed because of backgrounding. If none of the previous three work for you, then the next choice is to wait for the app to come into the foreground. And here you will need to write some code to manage some state to say, yep, a service was running, the app went into the background, and it needs to be restarted, and here are the parameters to start the job. Now, earlier when I started talking about on this little section here, we mentioned implicit broadcasts. And how there are some limitations on those now and how they can negatively impact a system. Well, guess what? There are also limitations on your broadcast receivers. The first and most important one is an application can't statically register for an implicit broadcast. Now, as I said, an implicit broadcast is a to whom it may concern. You can't register for those in the manifest anymore. However, you can register for explicit broadcasts. So explicit broadcasts are targeted, and usually they're from one application to another, or they're within the same application. So you may have one part of your system that when it's done some work, say a service, fires off an explicit broadcast that targets another part of your application with a message. Those are okay. You can still register for those within the Android manifest because those are targeted. It's the more general, the broad, to whom it may concern kind of messages. You can no longer register in the Android manifest. And again, this gets back to implicit broadcasts in the past have sort of had this tendency of waking up the device and starting up a whole bunch of things and using up a lot of power and contending for a lot of resources, which in some cases kind of ruined the overall Android experience for all users, or for users, despite the app, despite how well behaved your app might be. Now, it's okay to register for implicit intents or implicit broadcasts inside your activity. So your activity wakes up, it can then register to receive these implicit broadcasts, and then likewise when the activity is being shut down or being paused, it unregisters. So that's still okay. So your app can still receive implicit broadcasts, just it's doing so dynamically whenever the app is in the foreground. It registers and unregisters as appropriate. There are some implicit broadcasts which have been whitelisted. So these ones you can still register for, and your best bet is to go ahead and read Google's documentation here. That is the complete list of the implicit broadcasts which have been whitelisted. And the other thing of interest would be the job scheduling APIs that I mentioned just a few minutes ago. They can be scheduled to watch for certain broadcasts. So now, in some ways, your app, if you are restructuring things to take advantage of jobs, doesn't have to statically register for a broadcast. Instead, you can write a job that will say, oh, when the device is plugged in, please run this job. And then now, getting back to our example of having 6 apps that want to do something when the device is plugged in, now instead of all these apps waking up at the same time and contending for resources at the same time, the job scheduling frameworks can queue them up so that they maybe say run in order, or maybe say 2 or 3 at a time. And it does a better job of balancing the load on the device. So as far as the user is concerned, the device is still running fine. It's still running great. And as far as the apps are concerned, well, their work is still getting done in roughly the same time frame and the same fashion that the original application developer intended. So everyone is happy. Okay, let's just take a quick peek at picture-in-picture and how that's implemented in Android. Now, picture-in-picture, it basically is just a way for an activity to continually display its content in one corner of the screen, that corner being picked by Android at the time the activity enters the picture-in-picture mode. An activity must declare that it supports picture-in-picture, and then there is some code, some plumbing that must be invoked as the activity itself switches in and out of picture-in-picture mode. So you can sort of see an example of picture-in-picture mode here in this little animation from the Android developer website. And let's now take a quick peek as to how we would do something like this in Xamarin Android. Well, the first thing, as we said, the activity itself must declare picture-in-picture support. As we can see here, the main activity, it inherits from app-compat activity, and the activity attribute itself has a new property called supports picture-in-picture, which gets set to true or false. And that is really, as a bare minimum, all you need to do to declare picture-in-picture support for a given activity. It's generally considered to be a good practice for your activity to handle the configuration changes. As you can recall, with Android, when an activity undergoes a configuration change, i.e. it's rotated 90, the device is rotated 90 degrees, the activity is torn down and then recreated. So now you want your activity to handle those configuration changes. You don't necessarily want Android to come in, destroy everything, and then rebuild it for you. This could be particularly disruptive when it comes to, say, streaming media of some sort. The video is playing, all of a sudden it stops, and then it picks up again. You don't want that happening. So with picture-in-picture, in a lot of cases, it becomes the responsibility of the activity to handle those configuration changes. And we just list some of the more common configuration changes that your activity might want to handle. Not all of them, doesn't have to handle all of them necessarily, but that's kind of the set, the more common scenarios that need to be handled. Now, to switch to picture-in-picture mode, your activity just has to call this new method, enter picture-in-picture mode, and it provides some parameters. The enter picture-in-picture mode will return true once you have switched to picture-in-picture mode, or if you are already in picture-in-picture mode, it will still return true, and it will return false if for some reason it couldn't. The picture-in-picture params is a new API in Android 8, and it's just basically provides some information to Android with how it should initialize the picture-in-picture window. You don't actually instantiate a picture-in-picture params directly. Instead, you will use a builder class in the Fluent interface it provides. And this is a quick peek at the interface and some of the methods it provides. Set aspect ratio, set source rectangle hint, So the aspect ratio for the video or for the window itself, and then the rectangle hint. Just maybe you want to give Android a little bit of some clues as to how it should display the window itself. And then the other one there, set actions. The picture-in-picture window may have some controls or actions that can happen, such as a pause or a stop, that kind of a thing. You can add those as actions via the builder. And so you'd call this method, create your picture-in-picture params, and away you go. Your device is running in picture-in-picture mode. Or, sorry, your activity is running in picture-in-picture mode. Now, as the activity enters or leaves picture-in-picture mode, Android will invoke this method, on picture-in-picture mode changed. And this is your activity's chance to update the UI in response to exiting or entering picture-in-picture mode. So if you are in picture-in-picture mode, you maybe want to change the on-screen controls or widgets that the user may use to interact with the activity. And likewise, when you exit picture-in-picture mode, you want to restore them. You want to put them back. And this would be the hook for handling that change. Now, you may have noticed some applications, instead of going into the background, they pop themselves into picture-in-picture mode. Google Maps is a great example of this, where if you're navigating with it and then you quickly go to send a text, well, the Google Maps stays in picture-in-picture mode on your screen, and you can still enter your text. So while you're walking around downtown, you can still see where you're going and text your friend how you're getting there. Very handy. So you can do that by overriding the onUserLeave hint method on an activity. Now, somewhere in your activity, you would set a flag saying that, you know what, when you go into the background, go into picture-in-picture mode. It's perhaps not always relevant to be in picture-in-picture mode, so this is for those types of cases. That's why you would have this kind of a flag. And when you detect that, yes, I want to be in picture-in-picture mode as the user is leaving my activity, you would just call enter picture-in-picture mode, build the parameters, and there you go. And then when your activity comes back into the foreground, again, you would respond accordingly, update the UI to go from picture-in-picture mode to full screen mode, and that kind of a thing. So that's picture-in-picture mode. Just a quick overview. Not a lot of code changes there. Let's take a peek at what's new with the text view. Now, the text view itself doesn't have a lot of changes. It did receive some big bumps in terms of fonts, which generally we display in things like text view and all its various subclasses. So let's take a peek, a look at all of those things here in this next section. The quickest, most simplest thing to talk about is auto size. What happens now with text view auto sizing is the text that's displayed in the text view will increase or decrease in size to fill the layout. So before, as you can sort of see on the left, we have a big text view and the font doesn't change size. So we have little text, a lot of white space, or purple space in this case. Now on the right, if we do turn on auto sizing, as the text view grew in size or expanded in size, the font automatically increased to fill that text view. Now, it's possible to do this programmatically, and a lot of you may have already written some code or libraries to do that. But that can result in a lot of unnecessary extra code, a lot of plumbing code that you don't want to necessarily want to maintain going forward or mess around with. And let's face it, the typeface APIs and trying to detect how big your font should or shouldn't be can be a bit of a pain in the butt. So now, thanks to Android 8.0, we have this built in. So we'll see here that there are 4 new properties added to a text view in API 26. The text type, min text size, max text size, and step granularity. The only property you have to set is the text type, and that can be either uniform or none. So uniform meaning grow or contract the font text size as the text view changes size. And then the other 3 provide some hints to Android as to what it should do or how it should increase the font sizes or decrease the font sizes. So min size says this is the smallest a font can be, max size, the biggest a font can be, and the step granularity says as it is time to increase or decrease the font size, decrease it by this amount. So the values I show here are the defaults, 12 SP for the minimum, 112 for the maximum, and change by 2 SPs every single time you need to change the font. Again, you can set the own in your app as is appropriate for your needs. Of course, this again, backwardly supported with the support library. The trick here would be, first and foremost, make sure you subclass the app compat activity. If you don't do that, none of this will work. And it's an easy enough thing to miss. A lot of times you just reflexively subclass activity, and guess what? The support library won't work with that. You need the app compat activity. The other thing you would do is you would declare the app namespace, and you can see it there, linear layout, and we first identify the Android namespace, and then we declare the app namespace. And then now when we identify our properties, we will just declare them using the app : prefix. So app : auto text size type equals uniform. And now all of a sudden this text view will work on Android API level 26 and even those that are older, all the way back to 14. Next, let's take a peek at the autofill framework. So the autofill framework actually has two parts to it. The first part is an autofill service, which is running in the background. And the idea is that the autofill service will scan an activity, the widgets on an activity, for hints, and it will fill out forms that may be on an activity for the user. It's important to realize the autofill service just provides data. It doesn't do any data validation or that kind of a thing. That's still up to your application to do. But it does save the user a lot of taps and that kind of a thing when it comes to filling out some common forms. You can sort of see here on the right an example of the various autofill services running on my Android device. So I have autofill with Google and I have 1Password. And I use 1Password to fill in my username and password on apps that are configured to support autofill. The standard views that are provided in Android will now support autofill just out of the box. There's nothing to do. Well, you have to add a little bit of metadata, but we'll see that in a second. It is, of course, possible to create your own autofill service, but I'm not going to dive into that. I'm just going to show you what your app has to do to be able to take advantage of an autofill service. And really, it's just a matter of adding in just one new attribute to an element. So you can see here the edit text now has an autofill hints equals password. There are other ones available, such as credit card, phone number, postal code, email address, that kind of a thing. When you fill this autofill hints with one of those hints, now when your application displays an activity, it can interact with the autofill service and fill these fields as appropriate for the user. And that's really all you need to do, is just add in this extra attribute, give it the hint, and then away you go. And voila, autofill enabled. Now fonts and emojis are next. Perhaps not strictly a text view thing, but before this, text views and edit views didn't really support emojis and fonts, or fonts could be done, but not very easily. So let's take a look at these two things. We'll first start with fonts. So as I've said before, some of us in the past may have written our own code to use our own custom fonts. That debatably can be a bit painful, a bit cumbersome to use. And Google has realized that fonts themselves can go a long way to improving the look and the feel and the theme and the style of an application. So they have decided to build font support in for all their widgets into the Android framework. And of course, this again is backported to API level 14 with the Android support library. Google does provide us with a nice collection of fonts at their open source fonts collection at fonts.google.com. And we can just take advantage of those, or we can take advantage of other third-party fonts. This is all sort of encompassed by the font support provided in Android 8.0. So there's sort of two ways to use custom fonts in an Android application. Now, the first way is to embed them into the APK. And when you do that, they behave, the fonts that is, they behave a lot like an Android resource. And then the other way are downloadable fonts. And with downloadable fonts, your app will ask Android to go out and, well, download the fonts from somewhere for you. So let's first take a look at how we would package fonts within the APK itself. That's because downloading fonts sort of builds on this. So the first thing you do is you'd have to create a new directory in your application, resources/fonts. And because these are resources, the fonts that you add to the application will be local to that application. And you would just go ahead and add the necessary font files into that folder. And at that point, you can reference them in a text view by setting the font family attribute, or on an edit view, or that kind of a thing. And so you would just use like @font/ and then the name of the font file. And notice here we show the app compat version as well. So somewhere in your activity at the root element, you would have identified the app namespace. And now with these two declarations here for font family, the activity will always display that font for us. So that's great if you're just using, say one font. But what happens if your application has a couple of different fonts for the different styles, like say bold or italic or bold italic, or even with bold you have different weights of the font itself? Well, to deal with that, we can bundle similar fonts together as families. So this is just an XML file you would create in the fonts folder. And you would go ahead and add the font files themselves, and then you would organize the fonts into a font family, as we see here. So each font element within this font family is a file that is on our device. So we would have a file called lobster regular and a file called lobster italic. And then inside our application, when we set up our text view, we can say that, oh, the text style is italic and the font family is lobster. And now when Android goes to render that activity on the screen, it will pick out those two attributes and say, I need the lobster font, and it needs to be italic is the style. And it will pick from the font family the style that is most appropriate. If perchance Android can't find the font that matches the style, then it just falls back to the first font declared in the family. And that's basically embedding fonts inside your application. Now, downloadable fonts is an alternative to that. The advantage to downloadable fonts is, well, they don't bloat your APK, and they can be shared across multiple apps. So the way this works is each app talks to the Fonts Contract API. And the Fonts Contract itself is a wrapper around a font provider. Now, the job of a font provider is to go out and say, do I have this font installed on the device? If I do, great. Give it to the application. If I don't, go out and download it and add it to the font cache so that it can be then shared with other apps on the device. So this is a great way to share, if you have multiple apps, to have just one set of fonts for all apps rather than the same font repeated in each app. Now, the font provider there is one out of the box provided by Android. It comes with Google Play services. It's important to note that there will be certificates to help validate that what is being downloaded is what's supposed to be downloaded. And we'll see how that gets implemented here in a second. Now, when it comes to downloadable fonts, there's actually two ways those are supported. One of them is you can just upfront declare fonts to the app itself, and then when Android starts your app, it will go ahead and download the fonts when the app starts up. The other way is to dynamically or programmatically download the fonts. Odds are you probably want the first scenario, so let's dive into that first. So very similar to embedding fonts, you still have to declare your font resources, and you do that with a font family. Only now, instead of embedding font files and then identifying them in a font family, the font family declares or provides the metadata necessary to use a font provider. So Google provides us with a font provider out of the box with Google, or I shouldn't say out of the box, but with Google Play services. So in order to use that, that would have a different set of metadata than, say, a font provider from, oh, maybe Adobe. Regardless, all of the font providers have to have these 4 pieces of information that we're seeing here. So we would still create a font family, but now we identify the metadata. To be specific, we have to identify the font provider authority, the font provider package. We have to provide a query to help identify or isolate the fonts we want. And then we have to provide a resource array that has the SHA-1 checksums of the certificates used to help authenticate the payload that we're downloading from the internet or from some source. So all of this information here is kind of specific to the font provider in question. So here are just some generic examples, but these are kind of the 4 key pieces of information you need in order to be able to use a font provider. Now, to automatically download fonts, this is information that you would embed in your app as resources. So they're downloadable fonts, but they're still a little resourcey. The first thing you would do is you would declare the font in the font family in the resources like we saw. Then you would add a new file to your fonts that would identify each font family to be downloaded. The name of the file doesn't matter. In this example here, we've chosen preloaded fonts.xml, and it would look just like this. It's just a resource array, and it lists each of the font families that you want to download. So there's at least one, could be more. Then you would register the downloadable fonts in the manifest. And the way we do that is we create an application subclass, and we add the metadata attribute with the preloaded fonts key, and we specify the resource file of fonts that we want to download. So just to show you what it will add to the manifest, it just sticks metadata similar to that in the application. So now when Android starts up the app, and it will see that, oh, there is this preloaded fonts property or metadata set. I have to go and download all these fonts for the user, and it will proceed to do so for you. The other way is you may want to programmatically download fonts for some reason. Maybe certain parts of your screens, the fonts will change depending on the status of the user or the category of the user. To do that, you would create a font request, and notice that the font request has the standard font provider information for it. So the authority, the package, a font query, and then a resource array of font certificates. Then from there, when the fonts are done downloading, Android wants to let your app know about that. So your app has to create a new class which implements the font request callback interface. And that interface has 2 methods. OnTypeFace retrieved means that the font's downloaded. Great, you can start using them. OnTypeFace request failed, and an integer for the reason. Well, your fonts didn't download, so your app has to react accordingly. Maybe you just use the default system fonts, maybe it doesn't work. Again, this is up to the specifications of your application. Then when you have those 2 pieces in place, you can then proceed to actually go ahead and download the fonts. Now, of course, as we know, we shouldn't be blocking things on the main thread. We want to do all of this on a background thread. We want to keep the main thread responsive. And the way the fonts contract works is the request font method requires a thread that will be used to perform the actual downloading. And in this particular example here, we use the handler thread object. We just new one up. We give it a name. The name itself is primarily to help with debugging, so that you can see what that thread is being used for in logcat and that kind of a thing. We would start the thread, and then we just go ahead and call the request font method, and we give it the context that's making the request. Could be the activity, could be the application. We hand off the request object itself, the callback that should be used when the download is done, and we tell it download it on this thread. And at that point, the fonts will go off and download, and when they're done, well, Our app can respond to it according to the logic we have encoded in our callback. And finally, emojis. Emojis just make communication in the modern world a bit more fun. So this is an example of a lack of emoji support in the old Android world. Let's go eat something. You are something. What does all that mean exactly? Bit of confusion here. Once we add emojis, which, by the way, backwardly supported with the support library of v26, we can see that things brighten up a bit. All of a sudden, we have context, we have clarity. Let's go eat tacos. You are a unicorn. How do we get emoji support into our application? Well, it comes down to adding a NuGet package. 2, potentially 3 packages to install here. The first one is the Xamarin Android Support Emoji App Compat. That gives us the broadest base. It gives us backwards support to API level 14. If we're only targeting Android API level 26, we can use Xamarin Android Support Emoji, the first library that we see there. In both of those cases, either they will go and download the fonts necessary for emoji support. Now, that may not be optimal for our application. Maybe we want to have the emoji fonts bundled into the app. And in which case, we could also use the Xamarin Android Support Emoji bundled NuGet package that you see there. And all this does is just ensures that the emoji fonts are packaged into the application. Now, in the case of you're using one of the compatibility libraries there, the emoji support compat or the bundled, it is necessary to initialize the emoji compat library so that it can download the emojis for you. And we're kind of showing the code here. So we have the font request. We knew that up, and this is the font authority, font provider, the query string, and the certificates that you will need to make that request. So these certificates are provided by Google Play Services. So really, you just need to drop this code into your application. Then we knew up a config file, or we knew up an emoji compat.config, and this just provides the information necessary so that the emoji compat library can download the fonts for us. The set replace all just says replace the existing fonts you have with this one, and we register a callback. And then we just hand that off to the emoji compat.init, and away it will go and download it for us. And we usually do this in something like the application subclass. If we're using the bundled emojis, that becomes a lot easier. We just use the provided bundled emoji compat config, and we call init, and away it goes. So debatably, this can be easier, and if you're going to have to download apps or the fonts anyway, maybe in the case of emojis, this is one instance where you just use the bundled library. However, maybe you're using your own custom emojis or that kind of a thing, in which case you would use the previous example of downloading them from the appropriate font provider. And let's just take a quick spin at what some of the various widgets we get. The first one is the text view, and notice that the syntax for the widgets themselves is very similar. It's just those from the app compat library come with the word app compat inserted in there. So as well, when you're using the emoji app compat widgets, make sure that your activity subclasses app compat activity and not just the activity class from Android 8.0. Otherwise, again, things may or may not work as expected. So anyway, this is the text view, quick peek of it there. The next one would be the edit text, so you can now insert emojis into your messages or into your edit text as appropriate. And then finally, you can add emojis to buttons. So this brings us to the end of our talk. I encourage you to go out and see a little bit more on your own as to some of these new features. The Xamarin Android Monodroid samples does have a lot of the existing Android O samples ported over to C#, so you can take a peek at those on GitHub. The Android Developers channel on YouTube also has a lot of great videos, and they're sort of broken down to two levels of detail. One is just these little 5-minute taster videos that kind of give you a high-level overview, and then you can also find videos that are much longer, like half hour, an hour, which dive down into the nitty-gritty details of each of the features that we've sort of discussed here. And then, of course, finally, you would have to go and read the Android Oreo documentation themselves straight from Google. That provides debatably the best, most in-depth information about what is new in Android 8.0. And if you haven't done so already, I would strongly encourage you to go and visit xamarin.com/download, download Xamarin, and start developing a small little app. See how great it can be to start with mobile cross-platform development, particularly with Android as your first sample. So that brings us to the end of our talk. Thanks a lot for your time and sitting through and listening about all the changes. If you have any questions, we'll be sticking around for a while, so feel free to type them into the discussion box and we'll get you an answer. Again, my name is Tom Opkenorth. I'm a senior content developer, and it was great having the opportunity to present all this information for you guys. So, thanks once again, and have a great day. Thank you for joining us today. We are going to talk about Android Oreo 8.0 and the Visual Studio tools for Xamarin. My name is Tom Opkenorth, and I'm a senior content developer on the Xamarin Docs team. There, my job is to help with creating a lot of the content and guides, samples, that kind of a thing, with a focus mostly on Xamarin Android and Test Cloud, also known now as App Center Test. During the course of this discussion, you're probably going to have some questions that pop in.